Fine. Today we'll be doing your guided lab 6 for IS 2010. To find this assignment, please go to your week 7 module to find your guided lab 6. This is going to be a very long lab session, so I hope that you guys can follow along. Okay, let us begin. On our overview for what we're learning in Excel is database functions, logical functions, lookup and referencing, date and time functions, text function, sum ifs, and average ifs functions. For statistics, we'll be going over skewness, scatter diagrams, and correlation coefficients. As always, make sure you download this Lab 6 file and go ahead and open it. Once we have it open, let's go ahead and save the file as our appropriate naming scheme. First, select our database function, database worksheet. Okay. In cell I3, we want to go ahead and create a concat function. So the concat function will be equals concat. And we want to say the title be database, sales, summary. The next one is colon, space, quotation, and then comma, and go ahead and select cell L5. Go ahead and absolute it. Moving on, we want to select cell L5, and we want to go ahead and select a product category. So any one of these will do. I'm going to choose tablets. And we see that our title here has been updated to tablets. Moving on, we want to go ahead and do these appropriate database functions. So we have the first one for J4 being dsum. This is the sum. Go ahead and select your whole entire table. Oops, A3 through G103. Go ahead and absolute value all of them. Next thing we want to do is that we want to go ahead and do sales in quotation, comma. And next we want to do is that we want to have L4. So let's choose L4 through L5 and go ahead and absolute these two values. We see that we are going to get the sum of only tablets from our table here. This is what the dsum function does. It takes in our entire chart as our data, and then it looks over to our reference, which is tablets over here, and takes the sum of the sales, which is referenced by us saying sum of the sales column. Okay, next thing we want to do is that we want to do this for all these other ones based on their correct function. So this one would be the average. No, this one is the count. Next one is the max. This one is the min. Next thing we want to do is make sure that we have J4 and J5 selected, and then J7 and J8, and we want to make sure that they are in the currency format. If not, make sure you can press the $sign right here. Or, whoops, my bad, not that one. We want to go into the drop-down menu and check on these currency value. And then next we want to do is that we want to select cell L5, J6, my bad, and change it to numbers with no decimal. So change it to number with no decimal. Just that. Okay. Now next we want to go ahead and check our categories here. and see how it changes the chart. So rather than tablets, I want to say phones. Now we see our data has changed to the respective category. One more, let's go ahead and do laptop. See now that the data has changed once again. Okay, we are ready to move on to our logical functions. Go to the logical worksheet. Let's go ahead and select cell F4, and we're going to enter in this if statement right here. When we want to do this if statement right here, go ahead and copy and paste it over. Now, as we go through this function, let's understand what this is saying. So if is taken in a logical test, which is in this case E4 is either greater than or equal to 4. If this is true, we say that they are eligible. If it is not true, we say they are not eligible. So let's go ahead and analyze this. So let's look at our E4. So E4 is 1. So E4 is not greater than or equal to 4. So this function is going to throw out a not eligible. So next we want to do is that we want to go ahead and copy this entire formula all the way down. So go ahead and do that. Next thing we want to do is that we want to apply a conditional formatting to highlight those that are eligible for um, the bonus. So let's go ahead and highlight ourselves right here. Go to conditional formatting. We want to make a new rule. Go to use formula to determine which cells to format. First thing we want to do is that we want to start out with an equal signs. Next thing we want to do is that we want to select our cell F4, actually not select, type in F4. And then we're going to do an equal signs, and then we're going to do quotations, capital E, eligible. Go ahead and close that quotation. Now we want to format this as a yellow. So go ahead and choose a yellow. Then press OK. And then now we should see all the ones that are eligible are now yellow. Okay. Now we're moving on to high performers. So this is going to be our cell. Oops, my bad. We are going to be doing an AND function. My bad. We're going to be starting with cell G4. And then we are going to be doing an AND function. So let's go ahead and understand what it is. So identify employees with a performance rating greater than and equal to 4 years of experience, equal to 4 and years experience greater than equal to 5. Okay, so let's go and do an equals and. Go ahead and type this out. E4 greater than equal to 4, comma. Next thing we have is the D4 greater than equal sign to 5. I'll go ahead and close that. Let's see that this one is false. Let's go ahead and see if this is logically true. So our E4 is less than 4. So because this one is automatically false, we're going to return a false. So now we're going to go ahead and just bring this formula all the way down. And let's go ahead and analyze this one true right we have right here. Okay. So is our E6 greater than 4? Yes, that is true. Is our D6 greater than 5? Yes, that is also true. My bad. Is E6 greater than equal to 4? Yes, that is correct. So this is a true statement for that one row, and we can assume that the rest of them that say true are also true as well. Next thing we want to do is that we want to create a conditional formatting for high performers that are stated to be true. So let's go ahead and select all of our data again. Conditional formatting, go to new rule. We want to use a function to determine which cells to format again. Using equal signs here, we want to state that G4 is equal to, no quotations here, type in true, and go ahead and choose yellow again. I'm going to press OK, and now everywhere that we have true is yellow. Now, for training eligibility, we are going to be using our OR statement now. So we want to say, select cell H4, identify employees with a performance rating greater than or equal to 4, or years of experience greater than or equal to 5. So let's go ahead and do an OR formula here. So E4 is equal to 5, and then D4 is less than or equal to 2. See if this is true. So E4 Is E4 equal to 5? No. Okay, well, is D4 less than or equal to 2? No. So this statement will be false. Let's go ahead and drag down this formula. Let's look at this true statement right here. Let's look at, is E8 equal to 5? Yes, that is true. So we're automatically just going to throw a true here. And let's see if we can find one that is here. Yeah. So is E25 equal to 5? No. But is D25 less than or equal to 2? Yes, that is true. So we will throw a true here. Okay, next thing we want to do is that we want to again highlight ourselves to show that those who have true statements are highlighted yellow. So let's go ahead and do that. Go ahead and do conditional formatting. We want to do a new rule again. And then we want to choose use a formula to determine which cells to format. So now we want to do equals H4. And then we want to do now is equal to true. Going to press format, change the color to yellow, press OK, and press OK again. There we go. See now again that these ones are selected yellow. Next one we want to do is that we want to enter in our salary level. And we want to use this by using ifs. So I'm just going to go ahead and highlight this function that we have already stated right here. Go ahead and do this one. Now let's go ahead and understand what this formula is saying here. So ifs, we want to look at our cell C4 and say if C4 is less than 40,000, we want to say they have a low salary. If that is not true, we want to move on to our next logical statement and say if C4 is less than 70,000, then they have a medium salary. And finally, if this is not true, we want to move on to our last statement, which is if C4 is greater than or equal to 70,000, we state that they have a high salary income. The next thing we want to do is that we just want to highlight, go ahead and drag down our formulas all the way down. And then finally, for the last one here, for conditional formatting, we want to use it to highlight those that have a high level salary. So let's go ahead and highlight our data once again. Let's do conditional formatting. And then now we want to go ahead and do new rule. Use a formula to determine which cells to format. We want to do equals I4, and then equals quotations I, capital H, and then go ahead and choose format again, choose yellow, press OK, and press OK once again. Go ahead and double check that your sheet looks like mine, and if it does, we're ready to move on. Moving on to lookup and referencing. We are now going to be working with match, xmatch, index, and then nested match inside of index. And then finally, we're going to be working with unique and sort unique. Starting with cell K5, we want to go ahead and understand that the match function is used to locate items in a list or a table by returning the relative position of a specified value within a given range. So let's go ahead and type this out, equals match, J4, comma, we want to do our B4 all the way down to B3, and then I'm going to have to absolute all of those parentheses, go ahead and press enter. And the first thing that should show up is an NA, because when we're using match, we need to use our lookup value of J4 in order to find our current row number. So let's go ahead and enter in our any of these employee IDs. So I'm going to do 4, and we see that we have a row of 4. Let's go ahead and count 1, 2, 3, 4, and we see that employee ID 1004 is row 4. Row 2, 0, 2. And you see that row 2 has been selected, so 1, 2, and that is correct. That is consistent to what we want. Moving on, we now want to check our, we want to check by our name of employee to return a row. So let's go ahead and start with selecting K5, and then let's start with an equal signs match. J5, comma. Go ahead and select all of our employee names. 4. Go. Like again, we're going to have an NA here. And let's go ahead and start to search for our employee name. So I want to search up David Wilson. And we notice here that it is row 31 we're being pointed to. But if we notice here, we have a David Wilson at row 4. But let's go ahead and go to row 31. So row 31 is right here. We have a Daniel Harris. So something is not consistent with using the match function here. So something is going wrong. Let's go ahead and double check one more time if this is working properly. Let's go ahead and do James. See that our row returned is 38. Let's go to 38. And we are returning a correct name here. So we see that with our max match function that we are getting errors not consistent to what we wanted to say. This is where X match is going to come in. So let's go ahead and get started. So go ahead and select your cell K8, and we're going to go ahead and use Xmatch, which is a more advanced version, to locate our correct rows. So go ahead and use Xmatch. Go ahead and click this. Then we want to select our J8, comma. We want to do B4. So let's go ahead and do what we have above. This is correct. Let's do R31. Why not? And we have row 31. Is this consistent to our row 31? Yes, it is. Okay. Next, we want to do the same thing for our name like above. So what I can do here is drag down this formula, and then we can just go ahead and alter this a little bit. Rather than looking at column B, I want to say column C, and now let's go ahead and do David Wilson once again. We see now that we are throwing out the correct row of where David Wilson does show up. So Xmatch is more consistent to finding where we can find a correct instance of our name. Moving on now, we want to use the index function to return the values of cell at a specified row and column within a given range, making it useful for retrieving specific data points. So let's go ahead and select K12. And now we want to enter in the formula equals index. C4 through C53. So let's select all of your data. Go ahead and absolute all of them, comma. Now we want to select our J12. Go ahead and close parentheses. Go ahead and press enter. We're going to get a spill. That is fine. Now, next what we want to do is that we want to type in any row from column A, not the Excel row, but the ones that we have in here. So let's go ahead and start with something easy. So 1, we have James Anderson, which is consistent to what our row 1 should be. Now let's go ahead and do row 31 up above. And do we get Daniel Harris? Let's go ahead and look at row 31. We do get a Daniel Harris. Okay. Next thing we want to do is that we want to move on by get department by index number. So let's do K13. And then we can use the index function again. So this time I'm just going to copy it over. Change this from a C to a D. And then now I can go ahead and type in a row number. So I want to say 31 for Daniel Harris. Is Daniel Harris HR? Let's go ahead and check. He is HR. So we can see that our function does work. Moving on, we now want to work with nesting match inside of an index. So we'll combine the two, and we'll be starting on row K16. So go ahead and start with that. And we want to start with first an index function. And we want to select C, our C column. Go ahead and absolute, comma. Now we want to use our match function, no need for an equal signs here. This is where the nesting comes in. Next thing we want to do here, we want to select J17. Oops, my bad, J16. And then we want to go ahead and comma. And now we want to do our B column, which is our B. Go ahead and absolute. And then next thing we want to do is a comma. And then now we want to say is an exact match, which is 0. So go ahead and do 0. And go ahead and close parentheses twice. And go ahead and press enter. We're going to get a NA right here. So next thing we want to do is we want to go ahead and we want to name by index number. So let's go ahead and select 31. Want to go ahead and match our J16 with our B4. So let's go ahead and put in our employee ID. So 031, that, there we go. Now we're going to get a Daniel Harris, is that correct? As our employee name. There we go. Now we want to do department by index number. So let's go ahead and do what we had before. So with our absolutes, we should be able to drag it down and just change these to a D. And then this one to a J17, and this one now to a B for kick. And this is all good. Go ahead and press enter. And now I'm going to do it again, 1031. And we're going to get an HR now for Daniel Harris. But we already knew this, so let's go ahead and change this up. So now let's do 1045. Emma White, is that correct? Yes, Emma White is correct. And then let's go ahead and see what her department is. Is it IT? Yes, it is. So we know that our nested match inside of index does work. Okay. Moving on to the last part of this worksheet, we want to start using our unique function. Unique works by grabbing only unique functions in a distinct list of a column. So in this case, we want to return only the unique values found in departments. So let's go ahead and do that. Equals unique. Go ahead and select all your departments. Close parentheses. You can also absolute this. Now we have finance, HR, marketing, IT, and sales as our unique values. So we can use this as a way to filter out our items for future use as well. Now, if we wanted to sort the list using the unique function, we can use a nested function. So we can do this. I'm just going to go ahead and use equals sort unique and go ahead now and select all of our departments. Go ahead and close. Go ahead, these, but we can't want. And we see now that our list has returned a sorted list of departments in ascending order. So finance is correct, HR is correct, IT is in its correct spot, marketing, and then sales. Go ahead and make sure that your worksheet looks like mine. And then once it is, let's go ahead and move on to the next page. Now we want to work on our date and time worksheet. So let's go ahead and go here. We want to go ahead and start with cell D4, and we want to do date and time functions provide ways to extract details out of date data elements such as the month, the day of the week, and etc. as they allow us to perform date math, for example, the number of days between dates. So let's go ahead and start with D4 and enter in our year that our employee has been hired. So equals year, and I'm going to select cell D4. I'm going to press enter, and they're hired in the year 2012. Is that consistent? Yes, that is. Okay, the next thing we want to do is that we want to go ahead and drag down this formula. So that is applied for everyone. Now we want to do cell E4, and we want to go ahead and select month this time. Oops. And then go ahead and select B4 once again. Go ahead and close. And they were hired on the 7th month, which is correct with this 7 here. The next thing you want to do, just go ahead and drag that down to the rest. The day of hire, we want to now do equals day. Select B4. And then we have a 10, is that correct? Yes, 10 is correct with our B4 data. So let's go ahead and drag this down once again. Now, next what we want to do is we want to go ahead and enter in our days of the week that they were hired. So we don't see how they're hired, what day they were hired, but Excel is able to use equals text. Go ahead and open parentheses. And then now we want to go ahead and select B4. And now we need to give a date, day of the week value, which is in this case quotation, 4 Ds, and a quotation, close parentheses. And we see that we get a Tuesday printed out. So Excel works with dates really well, and then is able to throw out our day of the week that they were hired. Now we can go ahead and copy this all the way down, and we see that the rest of our employees have been hired on these days. Now, years of service, we want to calculate from today, how many years have they worked from when they were hired. So to do this, we are going to do an equals date diff, so date diff, which stands for date difference. Go ahead and select B4 as your first parameter. Go ahead and do comma. This is where we're subtracting by, which is today. And it's a function, so make sure you put the parentheses, comma, and this is how we want it to be formatted. We want to know by the year. So let's type in a Y for year, close parentheses, close quotation, close parentheses, press enter, and we see that we have 12 years of service. Now, we can also do, rather than years, we could change it to months, and we can see they've been working for 151 months, and we can also check how many days they've been working for, which is using B, and they've been working for 4,605 days. But we want to go ahead and make sure that we know how many years they've worked for, so go ahead and select Y again, and now we just need to drag down this function the whole way down. There we go. Now we are done with this worksheet. Go ahead and double check that yours looks like mine. And once it does, let's go ahead and move on to the next worksheet. We're now going to move over with text functions now. We've kind of worked with it on date and time, but we're going to go more in depth for here. So we want to go ahead and use text functions to provide various ways to manipulate text data, such as formatting, repeating, changing their case, and others. So let's go ahead and select cell F4. We want to go ahead and start with a text function. So go ahead and text C4. Go ahead and do comma, quotation, $, hashtag, comma, hashtag, hashtag, and then 0.00 quotation, close parentheses, and go and press enter. From this formula, we should understand what is happening here. So we are taking in cell C4 and we are formatting it to what we find appropriate. We are formatting it with a $sign first. Take it in the numbers and we need to put it in comma format. And then after that, we then want to have 2 decimal points. So if I were to change this to 0.0, we are going to get returned a 0 decimal point. If I do 2, we get 2 decimal points. Next, what we want to do is go ahead and copy this function the whole way down. So go ahead and do that. Now, next what we want to do is that we want to use the repetitive function, which is equals rept. Go ahead and open parentheses, select your B4, which is their job title. Go ahead and press and go ahead and do quotation, shift slash, go ahead and end quotation, and go ahead and press 3, close parentheses. And from here, we can see that we are printing out engineer, engineer, split, engineer, split, engineer, and then another split here. What this means is that, let's go ahead and analyze it. We are taking in our cell of B4, which is their engineering title. And then we are also adding on this string right here, which is this split index or character. And then we are printing it 3 times in a row. So we are going to get engineer, split, engineer, split, engineer, split. Now, next thing we want to do is that we want to go ahead and copy this all the way down. And we should see all of them are being repeated accordingly. Next thing we want to do is that we want to use equals upper. Equals upper is used to convert text convert all string text into uppercase. So go ahead and do equals upper, select cell A4, go ahead and close parentheses, and we see that all the characters of James Anderson are now capitalized. We should do this for the rest. So go ahead and bring it all the way down. Now, next one we want to do is lower function, so equals lower. This is the opposite of upper, where we are converting all the string text into all lowercase. So we see that the J and A in James Anderson has been lowercase. Go ahead and do it for the rest of them. And then we see that everything is lowercase. Now, next thing we want to use is the proper function. So equals proper. Proper function works like how you would do when editing any names. you would want to use proper formatting, which is capital first name, capital last name, and everything else lowercase. So let's go ahead and do equals proper. Go ahead and select your cell A4. And we should get a James Anderson, which is consistent to proper formatting, so nothing changes here. But let's go ahead and just drag this down. Okay, you may think that nothing has happened here, but let's go ahead and analyze our A6 cell, which is Olivia Thomas, which has a lowercase o and a lowercase t. And we go over to our J6, we see that the O and the T have been capitalized. And if you look at all of our highlighted cells, we see that they're all been properly uppercased. Okay, go ahead and make sure that your work looks like mine. If it does, let's go ahead and move on to the next worksheet, which is using SUMIFs and average ifs. Start with cell J6. We have worked with SUMIFs before. So in this one, we want to do the product cells of a certain product. So let's do SUMIFs. Want to do D4 all the way through its data, so D4 through D103, comma through 6, through I6. Ooh, I forgot to enter in my secondary criteria range, which is B, which is this one. Go ahead, enter. We see that we're getting a 0 thrown out because we have nothing typed in. So I'm going to type in tablets. And we see that we get the sum of all tablets from our data. Do is that I just want to absolute these values. Use of use. Next thing we want to do is use SUMIFs again to take in two criteria this time. So we want to take in our product type, and we want to take in our region as well. So what I'm going to do, I can copy and paste this function up above, drop it in this K9, and start editing some of these this formula to say I9 after this J9. I want to say this J9 should say I9. Let's go ahead and change it to I9. This should now highlight the F column. Go ahead and press comma and do J9. Go ahead and press enter. Okay, we have 0 as expected. Well, let's go ahead and do tablets again. And then for region, I'm just going to say south here, and we should see we now get a sum of those that are both from tablets and from the southern region, which is this sum here. We can also change this to east or west, whatever we want, and it should update accordingly. Moving on now, we want to work with average ifs. Average ifs works exactly how SUMIFs does, but instead of taking the sum, we are taking the average of our data. So let's start out with using our average function, so equals average ifs. Go ahead and select your cell D, column D. Go ahead and absolute, comma, and C, call it your C column. I'm going to absolute all this as well. Next thing I want to do is I want to select cell I12, which is right here. Close parentheses, go ahead and press enter. We should see that an error is being thrown out because we have nothing filled out at first. Now what I want to do is go ahead and type in tablets here. And we see that we got the average sale of $1,088.91. So this is how much per transaction we are making on a tablet sale. So this is correct. And we can also change this again to phones or whatever we want. So let's do phones for this. And we see that we're only making $797.50 on average per phone set. Okay, now we want to do the exact same thing we did for the region up above for SUMIFs, but this time we want to use average ifs. So rather than me typing it all out again, once we absolute all these values, I can Control C, copy this cell, Control V, drop it over here, and we can start editing this. So rather than saying J15, I can say that this is I15, do a comma. Now next we want to do is select our region, which is F4 through F103, comma, and then now select your empty region of J15, go to press enter. And now I want to say phones. Let's say north for this one. And we see that our average sale from the north is higher than our average sale overall. So it seems like we're making more money in the north region per phone. We can also change this again. Let's change this to east this time. And we see that we're making lower than the average from just look from our whole entire phones category. Yeah. Once your sheet looks like mine, go ahead and double check, and we're ready to move on to our next one, which is skewness. So let's move on to our sheet. From here, we are going to be working with these three data sets. So what we want to do is create histograms of these data sets. So I'm going to go ahead and select first column as our distribution one. So go ahead and make this a histogram, my bad. Go. This is our data set one. So go ahead and change the title to distribution one and then colon. And after this, we need to analyze what type of distribution this is. And it seems like this is symmetric, so I'm going to type in symmetric. And the next thing I want to do is I'm going to highlight our distribution 2, insert, our histogram. And I want to change this to say distribution 2, colon, and this one says pick any of the three from symmetric, positive skewed, or negatively skewed. And from what I'm seeing from this table, I'm going to say it's positively skewed. That, and we're going to do the exact same thing for the last table. So go ahead and choose distribution 3. Go ahead and do insert, histogram, and distribution 3. And analyzing with this chart this is negatively skewed. And just like that, we should be done with our charts and first skewness worksheet. Go ahead and double check that your work looks like mine, and we're ready to move on to our scatter worksheet. Okay, in our scatter worksheet, let's go ahead and understand what we are working with here. So we are working with three data sets again, and this time we want to show the correlation of these two from our study then exam score. So let's go ahead and select our cells for data set 1. I'm going to insert a scatter plot, just like that. And to make this easier for ourselves to show a correlation, I'm going to add in a trend line. So go ahead and press this plus button, press trend line. We see we have the trend line now added. And now I'm going to change this chart title as well to now say data set 1. So data set 1. And the next thing we want to do is we want to do the exact same thing for the other two. Let's go do that. So 2. And let's go ahead and add in a trend line. Finally, let's go ahead and do our last one. Once we've done that, we should go to our answers that we should answer. I mean, our questions we should answer to the right. So let's go ahead and look at that. The first thing we have is, in which data set do you observe the strongest correlation between hours studied and exam scores, and how can you tell? And the answer for this is data set 1 exhibits the strongest correlation between hours studied and exam scores. This is evident because the data points align closely, which is consistent to what we graphed here, along a center linear trend line in the scatter plot. The relationship appears consistent as hours study increases, exam scores also increase in a predictable manner. There is less variability in the data points around the trend line, meaning the exam scores increase steadily with the hours studied. So go ahead and analyzing this trend line here, we see that there are more groupings, or there is less variance in this case, to the trend line, which makes it a stronger correlation to the other two. As you can see, we see that there is more variance between the trend line and dataset 3, trend line, and we see that there is a higher variance among the trend line for dataset 3. So that should be your answer for how does the spread of data points change across the 3 datasets, and what does this indicate about the variability in exam scores. Like we said before, data 1 has the least spread, meaning low variability in exam scores. The points are clustered tightly around the trend line, suggesting a strong and predictable relationship between hours studied and exam scores. This indicates that study time is a reliable predictor of exam performance in the dataset. So data 1 represents a strong positive correlation where hours studied strongly predict exam scores, which is consistent to what we said above. And then we say for the other two, dataset 2 has moderate spread for what I said before. Data 3 has large spread, as I said before, for high variability. So you can go ahead and overlook this answer right here. Go ahead and copy it if you must, but understand what we are saying here for this question. Moving on, we want to go to correlation. Now we want to work with our correlation coefficient right here. So let's understand what correlation does here. Correlation is a numerical measure that quantifies the strength and direction of the relationship between two variables. It ranges from -1 to 1, where +1 indicates a positive correlation. As one variable increases, the other increases as well. 0 indicates a no correlation, as there is no relationship between the variables provided. -1 indicates a perfect negative correlation. As one variable increases, the other decreases. So now what we want to do is we want to go ahead and select our cell E3, go ahead and use the Correl function, and now we want to go ahead and select column, not column A, A4 through A53, comma. Now B4 through B53 as our second data. Go ahead and press enter. And what we see here is that we have a very strong correlation of 0.9782. This is very close to 1, meaning that there is a strong correlation with hours studied to exam score. So the more you study, the higher your exam score. So what we want to do next is we want to visualize this. So go ahead and select your data. Go ahead and use insert, and we want to go ahead and add in a scatter plot. We can see here and add a trend line that there is low variance and also, again, a very strong correlation to what is stated up above with this correlation coefficient as well. So the data is consistent to what we just saw. And now we want to go ahead and we can just go ahead and change this this chart to just say correlation graph. Naming doesn't really matter in this case. Any name you give it is a proper title. Yeah. Now we want to move on to our last part, which is our question. So question is, what does the correlation coefficient result indicate about this data set? This is also stated in the lab, stating that short term, the correlation coefficient in this case is close to 1, so it indicates a strong positive correlation between the hour studied and the exam scores. If you want to go more into depth about why this is, you can go ahead and look at this answer right here and go ahead and either short term the answer, or you can copy this word for word right here. This is the end of the workbook, so let's go ahead and turn this in. So I'm going to go ahead and close this Excel file. Let's go ahead and turn it in. Go ahead and find where you put your lab. Go ahead and press open. Once you have that green check, go ahead and press submit. And just like that, we have turned in our lab. Hey. I know this is a long one, and I know it may feel rushed, but please just look over the parts that you need to work on, as this is a video. And I hope you guys have a great day.